So I'm going to talk about one particular signal today. I guess we've seen the explosion of alt data. We've seen what's happened in the last few years. A lot of exciting signals, sentiment signals like Ravenpack, et cetera. And the question confronting quants like ourselves, because I've been around as sort of managing hedge funds, mutual funds, prop desks for the last 23 years. And the question confronting us is, well, we grew up with factor models. What are now known as smart betas in some circles. In fact, in our newest manifestation, we've started actually combining these hundreds of factors into smart betas and signals based on them that we're now actually licensing out. So that's a whole new gig, which we're calling quasi-machine intelligence technology, and hence QMIT. This particular paper was about investigating the sort of joint benefits of overlaying sentiment, for instance, Ravenpack on a factor-based signal like our LBO model. So this LBO model, we've got 20 years of data. We basically just use a bunch of factors to predict the likelihood of a buyout. But we don't just do it to maximize the takeout likelihood, because the classic problem with that sort of thing is that many of these stocks tend to go to zero before they get taken out. And so we've parsed this signal as a trading strategy. And so the objective is, first, you want to have a nice buyout hit rate, but at the same time, you also want to make sure that the returns are worth the bother. So, so let's just zip through the basics of this LBO model, and then I'll show you how to do the overlay and what we did in this paper, which I have to thank my colleague Arvind, who did most of the number crunching, and he's here somewhere. Thank you, Arvind, so he can take all the tough questions. All right, so what we've got is basically we just look at the top 100 names every week, rebalance with an equal weighted, you just take 1% times 100 names, very simple, right? And you get a long-term sort of 41% buyout hit rate, you get 22% annualized returns, 2.5 Sortino, et cetera, et cetera. The point is that actually, if you look at this chart on the left, on the first column, you've got the long-only LBOs, and you'll notice that the returns are pretty stupendous, but so is the vol, right? So you get a very ridiculously high number on the returns, 22 and change, but the vol's 24. Sharp still below 1, and you get some ridiculous drawdowns, 57.5%, but not bad, right? I mean, there's no portfolio construction here, there's no sector factor constraints, nothing going on, right? So this is just a raw signal. We basically trained on a bunch of factors, try to figure out what's going to get bought out, and over time, clearly, lots of these stocks do get bought out. 41% is not too shabby. And then we said, okay, well, obviously, long only, this is not too great. What if you hedge it? So if you hedge it against the S&P, vol comes all the way down to 11.6. So that's down by more than half. On the other hand, if you hedge it with the correct sort of factor, the correct style index, if you will, which is small cap value in this case, notice the vol now declines by to almost a third, and essentially you're down to less than 8. Of course, the returns go down substantially as well, and that's in the last column. Let me see if I can figure out how to point. I don't know what I'm pointing at, though. Wait. How do I point at something? Okay. All right, let's forget about pointing. All right, so the point is that, if you look at the returns by calendar year, you'll notice that actually, against the S&P, there's some significant down years. I mean, there's a lot more vol. Clearly, against the small cap value index, it's pretty remarkably steady, Eddie. No down years in 19, of course. It is a function of, when small cap and value does well, because you're looking at deep value type of names. So earlier this year, the longs ran up 27%. As small cap value fell out of favor, I don't have to tell you what's going on, what's happened in the last 9 trading days. We've got a historic factor rotation between growth and value, or rather momentum and value, and we've suddenly seen a huge resurgence in these small cap value type names. But the amazing thing is that against the appropriate value index, this long only model has no down years, does pretty well despite no kind of portfolio construction. Interestingly, unlike a lot of quant signals, you don't have any sort of post-crisis decay, and that shouldn't be too surprising. After all, the Fed juicing up the system with free money certainly doesn't hurt LBO type activity. The other thing which we'll get to is high level, the index characteristics against other hedge fund strategies worth remarking, because it's very uncorrelated to most other stuff in the quant signal world. So here's just a sort of smattering of some of the type of names that you're likely to see. It's going to be really heavy in consumer type names, your Kate Spade, those type of retail consumer. We've seen a bunch of those this year. A lot of tech names. I think in this you get Earthlink and Mentor Graphics, a few energy type related, Aljon, Refiners, Joy Global, things like that. Okay, so let's look at a couple of example buyouts. Rent-A-Center, Kate. This is just to give you a sense of what's happening. When we say that Rent-A-Center was in the model almost half of the time over the history that we looked at, till it finally got bought out in June of 18. So that's just sort of your 1-0 chart, and you can kind of see when it was in, when it was out. If you just take a dot product of each week that the stock's in the model with the weekly return, you just get an arithmetic 178% that you would have monetized before the stock gets bought out, right? So that's what's happening. We didn't do any compounding, just to give you rough numbers. Dot product, 1-0. Okay, so it doesn't actually matter if the stock is in the model when it gets bought out for you to monetize it. The real point of that slide was to tell you that what's propelling a lot of these names is not just the buyout premium. Of course, if you get lucky, it doesn't hurt to have the buyout premium, but what's propelling it is various catalysts along the way. It could be dividend hikes or buybacks or other correlated things, nice things that happen, like activists getting involved. In fact, if you run the LBO predictions against the 13 Fs of large activist funds, you might be pleasantly surprised that there's a pretty good overlap there. So you might ask, well, how did you do this? Is this, well, there's no deep learning, any of that stuff going on. We're still in the multi-factor construct. We're basically just taking, taming the factor zoo. You've got hundreds of factors. You're turning them into, highly optimized smart betas and using that to make the prediction. That's what's going on here. And this has really got to do with the broader construct of now how we're cranking out lots of signals based on these smart betas, where each of the deep value or enhanced momentum or all the stuff that quants are used to looking at, right? Revisions and ratings and targets and leverage and profitability and capital usage and all that kind of stuff. But we're optimizing it and sort of enhancing it by combining dozens of flavors of these things within each of the smart betas, if you will. And then actually how the smart betas themselves are created, that's a whole other story, because there's a lot of, that's where you could do different kinds of machine learning techniques and things get really interesting, but that's a whole separate talk. So let's just look at the risk profile. You've got, in this case, I told you earlier that once you hedge with small cap value, you're down to about less than 8%. That's, of course, realized vol. In this case, I've just given you the ex-ante against, using the Bloomberg risk model, and you've got 6 and change. So that's not surprising, because obviously risk has come down pretty dramatically relative to the previous 19 years. This chart is interesting because here we see that if you look at the R squared of the various, of the time series hedged, so this is sort of the LBO 100 minus the S&P against various HFR indices, you'll notice that actually the numbers in the first column are pretty low, and that just confirms what I had suggested earlier, that it's pretty uncorrelated to most hedge fund strategies. Interestingly, if you look at this one entry called HFRXMA, which is merger arb, it's pretty low against merger arb, and that shouldn't be too surprising once you think about the fact that here we're doing everything pre-announcement, whereas in merger arb people play the sort of post-announcement spread. So anyway, that's enough about the baseline LBO model. Now that I've told you how we're predicting the LBOs, I can move on to the actual, subject matter of this paper, which is how do we combine and overlay. So an obvious thought that came to us as well. We're just using factors. There's no real timely information in here. Wouldn't it be nice if we could try to incorporate the chatter from Raven-Pak sentiment and see what kind of difference that makes? And so we try to do that. The only problem we ran into is that Raven-Pak has, let's say, using the SESI signals, on average 288 stocks per day, but not a high number of intersections, because we're only looking at 100 predictions a day. Out of the 288, you get about 8 on average. Well, that's not a whole lot to play with, because if you just try to over-underweight 8 stocks, well, you're going to get a marginal sort of impact, right? So then we said, well, so the logical thing to do, and of course this is, for most real money accounts, you don't want to just trade a one-day sort of sentiment, so why don't we aggregate on 7-day, 30-day, 91 days and see how that goes? All right, so that's the sort of design of the experiment for this paper, if you will. You're going to take the base case SESI signal, which I'm sure Peter can tell you lots more about, and I believe that signal is defined as an excess sentiment, and that's a nice feature for what we're doing here. So we basically aggregate on these 3 horizons, and then we're going to essentially use 2 different ways. One is a simple moving average, and the other is a exponential moving average on the same window, and then try to look at how does the overlay work. So, all right, let's zip through this because I don't have too much time. So you'll notice that, now that we do the intersection, you get a lot more intersections, right? So on a quarterly basis, you got 63 stocks. That's not too shabby. It's much better than what we had before, which was 8. So the idea is very simple. There's 2 levers we can pull. Either you over-underweight based on what the z-score is of the Raven-Pak signal compared to the underlying, so the underlying position, right? The baseline is you got 1% of 100 stocks. So you're going to bump something up if the SESI exceeds a certain threshold. So in this case, we said, okay, if the SESI is between, it's higher than 1, but not over 2, then we'll take the 1%, make it 2%. And if it exceeds 2 sigma, then we'll overweight it to 3%. And conversely, on the downside, you're going to underweight to, half from 1 or all the way down to 0, right? So pretty simple stuff. Now, what else can you do? And we're going to find out in a second that this is good, but you don't get a lot of intersections, right? You're still getting, on a quarterly basis, 3 and 6, and exponential. Not a lot of stocks to play with still. So you get some pickup. You get a little 88 to 190 beeps on the return. There's some modest, very marginal pickup in the Sharpe ratio. Nothing much to write home about yet. So case 2, now you say, all right, let's reduce the z-score thresholds further. Instead of doing 1 and 2, why don't we do half and 1? And conversely, on the underweighting side, you get a few more stocks. So now you got 6 and 11 on the quarterly exponential. And the results, oops, went through that too quick. And the results look a little better, not surprisingly, but the intersection set is still too low. So let's go to the next step, and we say, okay, now why don't we just drop the z-score bound all the way to 0? Things start looking better now, and notice that given that you've got a partition at 0, both the exponential and simple moving averages will have the same number of total intersections. So like in the last 2 columns, you'll notice 28 plus 35, same as 27 plus 36. So now you've got the same number of predictions in both that you can over-underweight, but obviously the exponential's got a much faster decay, so it'll look a bit different. It turns out actually that's why the simple moving average does much better, because you got a lot more stocks to play with. And the fact that it does tells you that there's some information in there. Clearly there's some demonstrable alpha and Sharpe pickup that you'll see at the end of the day. So now, at this stage, we've already seen up to 3% in the best case scenario. Annualized returns, Sharpe improved by almost 20%, not too shabby. Let's keep going. Well, we haven't really monetized the information on the short side of the ledger, so why don't we do that now? So in this case, we're going to drop the z-score requirement and start underweighting, so actually explicitly shorting stocks, not just underweighting. That's the difference here, okay? So still same number of intersection signals, but you get a little more of a pickup. So let's jump to the final case in the interest of time and notice that, all right, So here's the final story. In the last case, we've now done sort of a slightly more exacerbated version of this experiment where we've now explicitly shorted stocks. And the sort of upshot of all this is that on a quarterly basis, if you do a simple moving average, you get pretty impressive numbers, right? And so for the 10-year overlapping study that we did, you saw, in this case, 864 basis point annualized pickup. Sharpe ratio improves by almost 50%. So yeah, overall, I would say, the SMA 1 quarter, not too shabby at all. So that's a pretty impressive result that we finally came up with, and that's kind of the summary. It shows you for each of those 10 years. In the highlighted column, you can see that in down years for Russell small cap value, it really adds a lot of value, which would suggest that the short side's kicking in, right? So Russell's down 29%, and the overlay is adding close to 9%, and so on, right? Okay, so that's kind of to wrap it up. We've got a model now that does predictions for LBOs. You got a nice long-term hit rate. It can be traded profitably as a long-term sort of as a very low turnover buy and hold kind of thing, or you can hedge it against the appropriate index, do some factor sector constraints, and get a much better Sharpe Sortino. You do it with the overlay. Of course, it's going to look a lot better. I'll let you figure out the T cost and turnover and what that those implications might be for your portfolio, but that's generally the idea of the experiment. So, questions?
We got one question right in the back.
Why an overlay? Why not just use information as an extra factor, and merge it by whatever rule of the book or whichever way you do?
Yeah, that's perfectly valid. You should try it. We were trying to give you the decomposition of the effects, right? The benefit of an overlay is to give you A plus B.
We have some questions on Slido, Susan.
Yep, so we've got some questions here. Have you tried using 13F data in your factor constructs? No, because we're actually, it turns out that what we're predicting often coincides with the 13Fs, right? Like we're almost anticipating the activist positions, if you will. And that's the benefit of the model, is that if you anticipate Elliott getting into the stock, you're going to see the pop, right? It's too late if you are following Elliott after the announcement. You're probably not going to see the same benefit. So, no.
Great. Milind Sharma, everybody. Thank you.
This is Raven Pack.